So welcome to another episode of the Belinda Carr Show. Today we're going to be talking about 3D printed homes. So I've tackled this topic a few times so far, and for most part, I always talk about 3D concrete printed homes. Today we're going to be talking to a company that does something slightly different. They print with plastic. Now, as we all know, plastic pollution is a huge issue around the world, not just in the States, but this company based in California called Azure Printed Homes actually prints ADUs and backyard studios with 60% recycled plastic material. So to learn a little bit more about the company, we've got Ross Maguire with us, CEO and co-founder of Azure. Thanks for joining us, Ross.
Thank you for having us.
Yeah. So I looked at your LinkedIn profile and did a little bit of research into your background. Seems like you've been in the construction field for quite a long time, and you identified certain problems in the field. And in 2019, you chose to tackle all those problems you identified. So tell us a little bit about your experience in the construction field.
Sure. Yeah, it's been kind of an evolution. My background starts in construction. It started, I guess, with my university degree back in the UK. Where I did a master's in civil engineering, and straight from university I joined at the time one of the largest general contractors in the UK. Had some fantastic experience there with some pretty high profile projects, and then ran my own company in the UK, consulting and running projects. And I've seen here since I moved to the States, the same kind of issues that I guess have been inherent in construction for years and years. And there's been kind of minor tweaks that have addressed and improved some of the processes, but fundamentally the fact that we're still using the same methods and means of producing houses and yeah, not just in residential but in commercial building as well, the same means and methods that haven't kind of evolved the same way that other industries have over the years. Yeah, we see that construction needs to be improved and updated, and that's what we've tried to do.
So in 2019, when you started coming up with this business, why did you gravitate towards 3D printing?
It was definitely a evolution. It didn't necessarily start there. We started Azure initially as a general contracting company, always with the vision of being innovative, being trustworthy, timely, things that we saw as being failures in construction in general for client and contractor interactions. So we didn't necessarily start immediately with 3D printing, but it's something that we saw the technology was evolving and getting stronger as we were in our early stages. And for the early adoption of 3D printing, we saw an area, as you said, a lot of people are using cement-based products to 3D print with. And we saw another way that 3D printing could be harnessed and utilized to create something even more efficient and even more, I guess, pain point removing for future building. So
you all identified plastic as building material.
Yeah, we saw, it's funny because we kind of had the concept before we knew necessarily how to produce it. So we knew what we wanted to do. We spoke to hundreds of people across the globe, basically, lots of Zoom calls like this, fact finding and finding what was out there currently and how we could use it to create what we wanted to. And we kind of found that, yeah, as new as what our vision is, nothing currently existed. So we went to a point where we're customizing a 3D printer that can print the size that we want, and taking the recycled plastic material, and I'm just noticing, I'm not sure if you can hear it, and I'm sorry for interrupting, but my business partner's next door, so I'm not sure if there's like him being on the call is coming through.
So what sort of plastic do y'all use? HDPE? High density polyethylene?
It's a PETG.
PETG.
So it's plastic bottles, plastic food packaging, the polymer most frequently used in those sorts of scenarios. We add a few things to it to give it more strength and durability. So we add fiberglass, which is a big part of it, and also like UV stabilizers that give it protection from the sun and whatnot.
So I know your process is probably proprietary, but I'm just interested in how you all make that sort of material structural. So do you all create plastic pellets and then melt that down and mix it with fibers and, like you talked about, stabilizers and stuff?
Yeah, so there's a compounding process that our suppliers produce for us. So they take the raw recycled plastic and then compound it into, as you say, the pellets is what we print with. So they compound the pellets ready for us to dry and then put into our extruder. So
it's very similar to the consumer 3D printer that we have in homes, like with the PLA and ABS printers. It's just PETG materials and has fiber reinforcement in it.
Yeah, and being a pellet that we can feed our extruders in large quantities rather than like a filament that might be used for more kind of desktop printers. Yeah.
So how do you get around building codes that don't see plastic as a structural material? Do you all add extra reinforcement in the walls and the roof and floor?
How do we get it for who, sorry?
How do you get around building codes that don't see plastic as a structural material? Do you all have to add extra steel reinforcement in the walls and the floors and the roof?
So we have FEA models, so finite element analysis models, which give us the structural analysis of the entire building. And then for each, that's based on certain tensile strengths and strengths for the material itself. And then we prove that by having physical samples that are printed and then tested for their mechanical properties, so that we're effectively corroborating the entire structure from the FEA model analysis.
So you all don't need any sort of extra reinforcement while making these slabs?
It's just to kind of talk you through the process. So we print the whole structure monolithically. So there's no joints or no connections between parts. You might have seen from our design that we kind of have the, I guess from one orientation, it's like a capital D shape. Yeah. So at either end of the D, so to speak, we have open ends that we either fill with, we build that part conventionally. So we use steel stud framing to close the ends for the solid ends, and then people can customize. That's part of our release actually, so we're going to have a design configurator on our website where people can customize how much glass, how much solid wall, locations of doors and whatnot. They can customize that part of it. But yeah, in terms of the actual printed structure, it is purely the print itself. For when we've got scenarios where people do want to have completely open ends, where it's entirely glass, then at that point we have interior steel members that are kind of hidden within the print itself, but they're added afterwards. We see the whole efficiency as being the fact that we can print a structure that is self-supporting. It stands by itself within hours of being printed. So that day one print, and it takes less than 24 hours to print one module, we have a structure that's effectively watertight. it stands by itself. It's effectively having a, if you're comparing it with traditional construction, to have a framed, sheathed, waterproofed, siding finished, roof installed, any metal work to connect the walls to the roof completely done within like less than 24 hours of printing, which is, I guess you're asking the question about plastic. That's another beauty of the fact that we can make that plastic structural, is because it adds the other functions that other materials don't have, such as being our membrane for the structure as well. So it kind of combines almost like 7 trades into one less than 24-hour print. So that's where we kind of see the efficiency being harnessed by 3D printing.
So last year I visited Mighty Buildings facility in San Francisco, and their structure is similar to yours. It's like a C shape with one, almost like a thinner wall on the other end, the opposite end. But their curve was printed with a different material and basically covered up with drywall and hand plastered. And what y'all are doing seems to be like y'all are printing this C or a D shape horizontally and then lifting it up to create the structure. And then the open ends are filled in with glass. I mean, depending on what the customer wants, it could be filled in with glass, so it's completely see-through. When you say that, then that's very interesting, because you're removing that manual labor that I noticed at Mighty Buildings facility, where they had to manually put up drywall and they had to put up siding on the outside. Like everything they had 3D printed was hidden inside the wall.
We still, I mean, just to clarify, and sorry to interrupt, we still finish everything internally. So what we print for ourselves is, as I say, like the equivalent of a framed building. So it's ready then at that point for wiring, for plumbing. Then we do a spray foam insulation on the inside. Then we close it with a drywall and finishes on the inside. So the inside after the print is, at this point in time, we want to make it more automated. But at this point in time, it goes back to more of a manual installation. But it's that first part of the kind of structural creation from the 3D printer that is the big efficiency for this process currently.
So I really appreciate that you're using plastic as a building material, but if you're not using that as a final finish, then what steps are you automating? Because you said it's 7 trades in one, but what trades are you including in that? Because you still have to, like you said, add insulation after, spray foam insulation, and then drywall on the inside. You're finishing that out, finishing the seams and the drywall, spray painting that. And then what about the outside? Are you leaving that raw exposed plastic, or that's also finished?
Yeah, the only finish that we apply on the outside is a coating, which gives us an enhanced UV protection as well. So if it effectively gets painted after it's been printed, and that's all we do to the exterior. So the 7 trades are effectively, framing it, sheathing it, putting a membrane on the exterior, putting a roof on it, putting a siding onto the exterior, and then any kind of metal connections that you would normally have between a roof and a siding finish.
Okay, got it.
I was going to say it's the exterior that sees the biggest efficiency improvement from being able to 3D print with plastic, because the fact that we've made it structural, and then using the fact that plastic provides us with that waterproof and sealing membrane on the exterior, just takes away kind of all those trades, and not just the materials, but the time involved in installing them as well.
Got it. So when I've visited a lot of 3D printed, when I visited a lot of 3D concrete printed homes, I've noticed micro fractures once the concrete cures. Is that something plastic has an issue with, or that's something that's eliminated?
No, I mean, I'll be transparent. We don't have that issue. The issue we more deal with, and I guess to a lesser extent in construction because we're not necessarily working to the same tolerances, but there's companies in aerospace that maybe use a similar material to us that are working to much tighter tolerances, and the thing that is experienced with glass reinforced PETG is some warping. So as you're printing the curing process, where it's reducing in heat from, it usually comes out around 250 degrees C down to room temperature, and as you're building it layer by layer, you sometimes see a little bit of warp as the structure is getting higher, just from the adhesion and I guess the cooling stresses that you get from layer to layer. So, but I mean, across the size of the unit that we're printing, they're fairly minimal and well within kind of construction tolerances. So it doesn't necessarily affect us. But yeah, no, I mean, the fact that it's plastic, it means that we don't get it's much more of an elastic material, that we don't see the same kind of fissures that you might see in concrete.
So since y'all aren't printing a double wall of plastic like they do with concrete, have you all thought about pouring this recycled plastic PETG material in a reusable mold and creating a single solid form rather than using a printer? What's the advantage of one over the other?
The advantage for printing that we see is being able to create that structure that is monolithically one piece, because we're as I say, we kind of, and you've seen the print and that it's stood up. We can stand up that unit after it's been printed, and it's a structure. It's ready to go. It's ready to be wired. It's ready to be plumbed and insulated. To injection mold, we would be doing it in parts. We wouldn't be able to create the structure that we have. We wouldn't be able to create the exterior wall geometries that give us our strength, because there's so many hollow sections that it would just end up being a number of smaller parts that we're then having to build together, and then you're kind of going back to, I guess, panel construction, which, yeah, for us, we just see it as being what we have as being the most efficient use, because we've come up with this design and appearance, but it's kind of just the tip of the iceberg in terms of what where it can be taken, because it's effectively the concept for how this can be built, but the designs and the ways that it can be interpreted moving forward are endless. So whether we get to a point where people can effectively completely customize their own units, that's where we want to get to eventually. But obviously our starting place is to refine the formula to a point where the efficiencies are so great that it's giving people time and cost savings that we haven't seen previously. So
yeah, so let's talk a little bit more about the designs that you just mentioned. You all have a backyard studio, which is around 120 square feet, and you all are selling that for $24,900. You'll also have a larger ADU, or additional dwelling unit, which can vary from 360 square feet to 900 square feet. On the lower end, that costs around $79,900 or $80,000. Those are pretty good prices compared to some of the other ADUs I've seen coming out of California. What sort of reaction or excitement have y'all seen in the market when y'all propose this to the people in California?
I mean, we started a very low level of marketing at the beginning of the year, and we kind of had to turn it off shortly afterwards, because yeah, we were inundated. We got within the first 2 weeks, I think we ended up having about 70 inquiries each day. And and that was obviously an early stage in our development. So it was almost a, let's turn the tap on to see what the reaction is, and then just to know that the demand is there, and sure enough it was. So we turned down kind of our spend on marketing at that point. So but even just from that short period of time, we made pre-sales close to $4 million worth. So we've effectively booked our at least first 2 months of production. So
That's
yeah.
awesome. Congrats.
Yeah, thank you.
So have you all sold any final units yet? Have you all shipped it out, or it's still not at that point yet?
No, we have our first printer being assembled in our facility at the moment. So we expect to be starting production in the next few months. So hopefully by the back end of the summer, we'll be producing what will be one unit, one module per day off of the one printer, and then we hope to add a further a second and a third printer as well, so that by the end of the year we're producing 3 units each day just in this facility here.
So when you say producing each unit, you mean producing the shell of the unit, and then the finishing is done later at your facility, or do you all do that somewhere else?
Yeah, all done in our facility, yes. So the rate will be one being produced each day, as in we'll continue that same speed with the rest of the assembly line as well. So as one is being printed each day, it'll also be one being shipped each day as well.
Got it. Okay. So the backyard studio doesn't seem to have any plumbing integrated into it. That's just purely just electrical hookups.
That's right. Yeah, yeah.
But the ADU would have a bathroom and a mini kitchen.
Yes, yeah. So, I mean, a little bit of the background in that strategy is, I guess, design and marketing strategy. And I guess I can't say off the record, but
if you don't want me to include in the video, you don't just tell me.
We'll see how it comes out. The 120 square feet is based on the fact that most cities, municipalities class that size as more of a shed size, which means that permitting wise, the homeowners wouldn't need to have a permit for those. And we've actually built a number of those size units over the last few years from people needing an office space or a workout space or a music studio or whatever they need, and it means that they can avoid the, I guess, delays from any red tape of having to permit a structure for their backyard. So keeping under that 120 square feet alleviates that time constraint in the process. But yeah, so nothing required for the structure. Obviously, check with your local city. But for any electrical connection, then that would have to obviously go through what would normally be an over-the-counter kind of permit, and the same for adding air conditioning. So yeah, and I guess if someone wanted to add a kitchen and or a bathroom, I mean, it's a very small unit to be able to do that too. But yeah, we kind of have designed it and marketed it as providing an office space or a workout space, or just an extra 120 square feet that is kind of hassle-free from a construction and permitting point of view. So, but
the ADUs would require a permit. Those are larger units.
Yeah, anything over 120 square feet in general is a permitted structure.
And I saw on your website you all have some sort of financing program set up for buyers.
Yes.
Okay. Then do you all also assist them in the permitting process and then getting other trades involved, like laying the foundation and then bringing a crane or something to put the structure in their backyards?
Yeah. We for the ones in the Southern California area, we'll do the foundations, or at least give the option of providing the foundations and any utility connections and delivery and crane lifts and whatnot. And we have partners in Northern California and neighboring states that will be able to do the same. So we will be guiding and assisting all clients through the process as well.
So when you say you have people in Northern California, have you franchised out this idea, or those are just people in your company that are going to help buyers locally?
Just local contractors that we work with. So they'll do the foundation side of things and any utility trenching and utility runs that would need to be done for any of the units. So yeah, we're, as you can kind of tell, we're trying to simplify the whole process and make it a lot more hassle-free than it should be otherwise for homeowners. So that's the whole intent. Yeah, by having these connections, we can organize the whole thing for owners after they make an order. So
that's very exciting. And you talked about a customizer tool on your website where people can select how large a unit they want, which sides they want glazing on, how large of a bathroom, and where they want their walls to be placed. And I guess that sort of customization is doable when you're printing each unit individually, because replacing the file that you send to the printer is not a big deal. But when it comes to finishing out the interiors, would that be a problem for you, because the size of the kitchenette would vary and the size of the cabinets would vary if you'll have such a wide degree of customization?
Yeah, we have set our own boundaries. So there'll be definitely parameters that will allow people to customize, but we'll keep it within our own level of movement, just so that we're not tying ourselves up. Because that's the other thing, is that and we're in the middle of fundraising at the moment, and part of that fundraising is to go towards inventory, so that we're not being tied down by long lead times and making all of these abilities to be efficient without then having the inventory to keep the production flow going. So no, yeah, I mean, in terms of the release, the backyard studios are going to be the first ones being produced, and that's what we have the design configurator for at the moment, and that's going to go live in the next few weeks, and then we'll replicate the same thing for the larger ADU units as well, where people will have that ability to customize their own unit. But as you say, yeah, it's going to be customizable within
a certain degree.
Yeah.
That's very exciting. So you got a lot. Sorry, go ahead.
I was going to say, for the backyard studio, we have like 3 different lighting options, 4 different interior finishes. Those 2 exterior walls that we mentioned are probably the most customizable. But we'll do a similar thing with the larger units. So maybe 4 or 5 different options on kitchen specifications, and the same for bathrooms. And then it'll end up being that there'll be thousands of different parameters or permutations of how you can configure a design, but at least it'll be from our kind of pool of options that we'll have inventory of.
Yeah, you all know what you're going to build, and because you all can have 100 different kitchenette options, the 100 different cabinet sizes, so you'll have to have some sort of control there. So it seems like you all are going to be very busy for the rest of the year. You said you're going to set up your facility and start printing towards the end of summer. What else do you have planned?
For the rest of the year, that's the facility ambitions. We're in the middle of having our unit stamped by ICC, which will make that whole permit process that we talked about a lot easier for people, not just in California, but across the state. So with ICC stamp, they'll be able to, someone in Dallas will be able to go onto the website and see that it's been evaluated and certified, and that will at least mean that the permit process will be slightly simpler than having to start from scratch with each state. So yeah, that's going through currently, and that will hopefully run concurrently with our current machine build. So around the same time that we start producing, we'll have that certification as well.
Very cool. So if people want to learn a little bit more about your company and perhaps even book a unit, what's the best way to reach out to y'all?
Through our website. So there's a pre-order now option. And as I was saying, the design configurator for the backyard studios should be ready to go live in the next couple of weeks. So people will be able to go onto the backyard studio section, click on the design and order, and they'll be able to configure the design. The price or cost will update as they make their selections, because they'll be able to add HVAC, they can add solar, they can add a solar battery, so they can be off grid if they choose to be. And yeah, they'll press the button and that'll add them to kind of our
very lengthy wait list.
Our production list of units. So yeah, the sooner they get in, the higher they'll be on our list. But with yeah, with what we're planning for the extra printers, we aim to be able to catch up with demand pretty quickly. And from that point onwards, we would be looking to do another round of fundraising next year, so that we can start looking at the next location as well. Because what we see with what we're doing is that rather than having kind of one macro factory in one location that serves the States, we would be setting up similar sized facilities to this across the areas that are seeing the most demand. So after this, it might be still in Southern California, but maybe in a slightly different area, and then moving north and then going into neighboring states after that. So yeah, we're seeing a lot of inquiries from the Western states and the Sunbelt states. So that's kind of how we see things growing beyond this. Once we've refined the formula here, then it will just grow and grow from location to location.
It's very exciting. And like I said several times during this podcast, the idea of using recycled plastic polymers in a building is exciting, and it's something that I believe has a lot of potential. I'm glad that someone's trying to tackle this problem. And I hope to see a live printing of one of these houses soon, once you get your printer set up and your facility and your factory set up too.
Absolutely. Yeah, no, you're welcome to come out and see it once it's up and running. Yeah, I mean, in terms of the environment, I have a young family. I have a daughter that just turned 2 and another one on the way. So it's something that has always been in my mind, but I guess it's become more and more prevalent as I'm getting older. And I feel like we just need to be more conscious and just a bit smarter about how we do things. Not just in construction, but across the board. So hopefully we're making a
change.
Improving it. Yeah.
Yeah, I completely agree. Well, thank you so much, Ross, for being on the podcast, and hope to meet you in person soon.
Yeah, likewise.
Thank you.
Thank you, Belinda.